Assalamu alaikum. Bismillah. Welcome to our JNCIS service provider course. That is service provider routing and switching specialist, JNCIS-SP. There is three modules here. Number one is intermediate routing. Number two is service provider switching. And last one is MPLS fundamentals. We have already completed first two module, routing and switching. Now we are discussing MPLS fundamentals. Okay. So we have already completed course introduction, MPLS introduction, and MPLS mechanics in last class. Okay. So today we discuss the module 4 under MPLS section. We are discussing today MPLS static LSP and the forwarding plan. So this is our today's topic, MPLS static LSP and forwarding plan. Okay. For this topic or module, we saw this lab. Okay. I'm using EFNG and my PMX iOS is standalone PMX and the version is 40. Okay, so just check one. Good. This is our PMX one. Default user ID is root and default password is root13. Okay, then CLI. So display set. So there is a basic configuration here. No extra configuration or MPLS or routing configuration not available here. Okay, we'll configure complete lab. So first, we start our theoretical concept and we'll go to our lab section. After completing theoretical section. But let's start our theoretical section. Junos fundamentals. Today we discuss MPLS. So the section is static LSP. LSP means levels is path and the forwarding plan. This module have 5 sections. Number 1 is configuring your network to host MPLS services. Number 2 is static LSP, how to configure static LSP, considering a different router role like egress router, ingress router, transit router like this. And number 3 section is static LSP, how to configure static LSP considering the transit routers. And this section 4 is basically lab topology discussion. And this is last one is a static LSP and a forwarding plan. So let's start configuring your network to host MPLS service. By using MPLS backbone, we can give a different type of service like MPLS L3 VPN, MPLS L2 VPN, and traffic engineering. Okay. Quality of service, different services we can ensure from MPLS pipeline or MPLS technology. Okay, so let's start. Here is some terminology we use at our MPLS journey. Number 1 is label. Label basically it's a numeric value. This value will be used in label distribution protocol. We can use LDP, level distribution protocol, for level distribution, or we can use RSVP, or we can use segment routing. Okay, so number two terminology is MPLS, multi-protocol level switching, and LSP means level switch path. Number three, transport level, ingress and egress router. A head-in is equal to ingress and tail-in is equal to egress. Provider is router. Basically, provider is a router is connected with customer is router. Okay. And provider router, basically provider router is core backbone router in MPLS topology. Customer edge router, there is no MPLS in customer router or customer edge router. They are communicating with P router as a normal IP routing. Push, swap, and pop operation. There are three operations in MPLS network. Number one is push. That means you MPLS router, that means P router, need to insert some label. That means the push. Swap means you can say the transit, just receiving one label in incoming as incoming label and sending another label as outgoing label to another router. That is called the swap operation. And the pop operation, last one is pop. Pop means just remove the label and send the normal IP packet to the last in router or egress router. So push means insert label, swap means just swapping the label, and pop is remove the MPLS label. Penultimate hop popping, this is the special router in MPLS backbone. We just by default, penultimate router is connected. Just consider our topology. That means uh, consider here is connected one C router here. This is C router, and another C router is connected with PMX1. So if I considering from this point, this router is ingress router and this router is egress router. So last second router will be the PHP router, penultimate hop popping. This behavior is by default. Okay, that means this PMX4 or PHP router removing the label and send to last egress router. So this is the concept of PHP, and let's move. The INET.3 table, when we complete MPLS configuration in our lab topology, we can show you the different table. Basically, in MPLS, there is three table is engaged with MPLS. Number one is INET.3 table, that is called the MPLS routing table, and MPLS.0 table. This is the level distribution table, that is called the MPLS.0 table. And another table is INET.0. You already know INET.0 is IPv4 Unicast table. Okay. Last one is level forwarding information base, that is the LFI. Basically, this is coming from control plan. This FIB is basically coming from control plan. Okay. So this is our terminology which is used our enter and PLS channel. So let's move for next base, putting the theory into practice. You have learned many new and important MPLS concepts. Some new terminology is here. New terminology, that means label. What is label? Label is a numeric number that is used to propagate your traffic or packet from one to another location. What is the difference between INET.3 and MPLS.table? This basic difference is INET.3 table is the MPLS routing table. Okay, and MPLS table, that is MPLS.0 table, it's solely responsible for MPLS level distribution. This is the basic difference between INET.3 table and MPLS.0 table. I will show you in our lab INET.3 table and MPLS.0 table how to make this table. Okay, but the basic difference is INET.3 is normally MPLS routing table and MPLS table is used for just level distribution. Okay, MPLS level. So level shim header, that is shim header because MPLS is inserted between layer 2 and layer 3, that is called shim header. This is the new terminology for MPLS. Push, I already share. Push means insert label. Pop means remove the label. Swap means swapping. Just in incoming interface router receiving the incoming label and set the another label when sending to another neighbor router. That is called the swapping. And penultimate hop penultimate or PSP hop popping means just last second router considering egress router uh, when removing MPLS label. This router is called the PSP router. New router roles. Router role is divided into basically three categories. Number one is ingress, egress, and transit. Ingress when you start, just starting the journey, when you start from starting router, that is you can say the PMX1 is the ingress router and PMX5 is called egress router. Just considering extended topology, here is connected one customer. Same customer is connected here for side 1. So when I considering from this point, this router is the ingress router, this router is the egress router. Between this router is the transit router. So ingress router also you can say the head-in router. Egress router, you can also say this is the tail-in router. This is the another name, but basic function is same. Okay, head-in router and tail-in. You can say also P router, provider raised router. P means provider router, C means customer raised router. So in our topology, the provider is, these are the provider raised router. These are the provider raised router. If you considering your customer is connected from here. Okay, your customer, that means C router is connected from here. You can say this is P router, provider edge router, and this is the customer edge router. In between these are the P router, provider router. Okay, this is the naming convention for MPLS, or you can say the terminal. New routing tables, INET.3 and MPLS.0. We will get new two routing table or two tables. You can say simply INET.3 and MPLS.0. You already know INET.0 is for IPv4 unicast, INET 6.0 is for IPv6 unicast. So for MPLS, the table will be different. The table name is INET.3 and the MPLS.0. So this is our topology here. Okay. So see here the router 1 is the customer router, customer side A, and same customer side B. See here you need to create a static LSP. You need to create a static LSP from router 5 to router 1. Router 5 to router 1. So considering router 1 to router 10 in a same is. So when you considering BGP, you have to fulfill the you have to complete the full mesh, or you can consider route server client concept, or you can consider BGP confederation concept. So if I consider a route server, like you can say router 2 is RR, primary error, or you can say router 7 is a secondary error. All other RR client will make BGP session with primary RR and backup RR. So this is router 1 is not directly connected with router 5. In that case, on directly connected next hop will need to be changed. Need to be changed. In eBGP, we already know next hop automatically change. But in IBGP, next hop don't automatically change. So need to make policy to change the next hop behavior in IBGP. So this is the question. This is the question. So you consider here, you configure the BGP. This BGP is eBGP. Customer sending this prefix through eBGP. Router 5 is receiving this prefix. This prefix installed in BGP route table. When receiving this prefix from router 1, what will be the next hop? What will be the next hop? So the next hop, if next hop should be router 5 loopback interface side. Okay, that will be the perfect next hop. So if you do this, you need to make policy. You need to make policy to change the next hop behavior in IBG. So this is the course. Okay. It's basically coming from BGP. You know better understand BGP, so you already understand what is discussed about this topic. The topology and IP scheme for this course or for this topology, just consider you have this topology. It's just for IP plan. They're sharing the IP plan, loopback IP. They are considering one block 192.168.1.x. X is the router number. So for router 1, the loopback will be 192.168.1.1. For router 10, your loopback will be 192.168.1.10. So this is your loopback plan. And what will be the point-to-point subnet, or what will be the point-to-point subnet plan? For point-to-point 10.x, first router is X, router 2 to 7. That means, example, point-to-point subnet, router 7 interface on the router 2, router 7. Router 7, you just configure router 2, router 7. Router 2, router 7. That means first X is router number. Second Y means second router number. That means 2, 7. And we configuring router 7 interface side. In that case, I configure .7. In router 2 side, the IP will be 2.7.2. And all point-to-point subnet here /24. So this is our loopback and point-to-point IP plan for lab. Is it okay? You understand IP plan, loopback IP and point-to-point subnet plan? Is it okay? Hello. So this topology will be used for our entire MPLS journey. And this is basically the IP plan. And see here, router 1, router 5, router 6, and router 10 are P routers. See here, router 1, router 6, router 5, router 10. These are P routers. And all others are pure transit. All others, that means router 2, 3, 4, 7, 8, 9. All others are pure transit, a BGP free port. A BGP free port. Here, using this word BGP free port, you can skip BGP in router 2, router 3, 4, 7, 8, 9. That's why they are called BGP free port. So this is our plan. First, we configure loopback IP in 10 routers, then configure point-to-point IP one by one. So let's go to our topology and finish the configuration first. First, start with loopback. So for router 1, see here, we configure set interface loopback 0, description loopback, set interface loopback 0, unit 0, family inet address, that is IPv4 address, and the IP is 192.168.1.1. Similarly, check other routers. We're checking other routers loopback. Is it configured, already configured or not? So last router 10. So for router 1, go to for router 2, its the rating is 0, 1, 2, 3, CLI, edit. Router 3, good. 4, good. Last router, 1 to 10. 2, 3, 7. So verify the configuration here. Router 2 loopback is 1.2. Router 3 loopback is 1.3. Router 4 1.4. 5 1.5. 6 router loopback is 1.6. 7 router loopback 1.7. And 8 router loopback is 1.8. Similarly 9. And last one is 10. So loopback interface configuration already done. Then go for point mount. So first we configure see here router 1 and this is the router 2. So first is X, that means router 1. Second is Y, that is 2. For router 1 side, the interface IP will be 1. Router 2 side, interface IP will be 2. So this is the tricks of IP configuration. Point for type finish. So first, I'm in PMX1. Set the interface IP configuration. Set interface GE-0 by 0 by 0 unit 0 description. The interface is connected with PMX2. PMX2. It is PMX2 and for unit 0 normally inet address will be 10.1.2.1/24. So this is this configuration. Copy this one for PMX2. Save interface and the description will be PMX1. IP configuration PMX2. This is 1.2.2/24. Then next PMX1 is also connect with PMX6 and the interface is C0/0/1. Just edit this, that is PMX6 and the interface would be 1.0.0.1 and IP address family inet address 10.1.6.1/24. Omit interface 1 and that will be router 6 and this is PMX1. Oh, this is the wrong configuration. This is wrong configuration. This configuration will be in PMX1, not PMX2. Sorry, it will be in PMX1. Let's remove. What is the difference between inet 3? After the class, could you share your image in lab file to report? Yes, of course. So this is PMX1 or another interface configuration done. That is two interfaces connected, C0/0 and 0/0/1. 0 is connected with BMX2 and 1 is connected with BMX6. Two configuration done. 0 and this is 6. 6 is IP. IP will be 6. 6/20. 6.6/20. Let's move to BMX2. BMX2 is connected with multiple router, BMX1, BMX3, and BMX7. So let's start. Already we configured IP address, which is connected with BMX1. And next, move BMX2 to BMX3. The interface is 0/0/1. So going to BMX2, interface, connect with BMX3. The interface will be 1. Interface will be 1. The IP address, family init address 0/0/1. This is 0/0/1. The interface IP is 10.2.3.2/24. Okay. 0/0/1 and 0/0/2. 0/0/2. 0/0/2. The interface is connected with BMX7 and the IP address to IP address will be 2.7. 2.7. 2.7.2. 2.7.2 in router 2. So cover this one. Check the interface configuration. Interface is 2 and going to router 7. That is router 2 and IP 7. IP would be 7.7. 7.7 in router 7. BMX2 is also connected with BMX3. BMX3 side interface is 0/0/1. So copy this one. BMX3, that is BMX2, and IP address will be 3.3. 3.3. 3.3. BMX2 interface IP configuration done. I think there is 3 interfaces connected with BMX2. 0 is connected with BMX1, 1 is connected with BMX3, and 2 is connected with 7. It's okay. Then we go to BMX3. BMX3 is connected with BMX4 and 8. So first one is G0/0/1. Okay. Next, BMX3 is connected with BMX4. Interface will be 2. Interface will be 2. IP address, family inet address 3.4. That means 10.3.4.3/24. Okay, this is one interface. Another interface is G0/0/3. And this interface is connected with PMX8. The IP address is 3 to 8. That means 3 to 8. 3.8.3/20. So interface configuration done in PMX3. 1, 2, 3. Okay. Let's go with router 4. Router 4, just copy this one. This is router 4. And connect with interface 2 with router 3. This interface IP will be 3.4.4. So interface 2 done. PMX4 is connected with PMX5 and the interface is 3. Interface is 3. 5. 4, 5. Dynamic address. The address is 10.4.5.4/24. Interface 3 done. Then interface 4. Interface 4 is connected with PMX9. IP address interface is 4. IP address is 10.4.9.9/20. 4 configuration, and then we go for router 5. The interface 4 to 5 interface is 3. To 5, that is 4, and interface is 3. It's okay. IP address will be 5.5. 4.5.5. And router 5 is also connect with router 10. 10 interface is interface 5. 5. This is 10. Familiar address. Address will be, this is 510. This X is 5, Y is 10, and router number is 5. 10, 5, 10, 5/20. Right. So this is interface configuration of router 5. Let's go to router 6. Router 6 is connected with router 7, and I already configure, and this is connected with router 1. It is another interface is 0, and the router is 7. 6 to 7. Okay. Then Finally, I need address. Yeah, address will be 6 to 7. This is 6. This is 7. 7.6 first into router 6 configuration done. Then we go for 7. 7 is connected with router 6. Router 6 interface is 0. So copy this one. That is 6. And IP will be what is the difference with using the another Juniper? Yes, with this, yeah. Um, Basically, there is no difference. I use here the version is 14. That is very old. And if you configure VCP and VP, you will get update version like 22 or 23. Okay. But this EVNG image will take more resources, RAM and CPU. That's why I use this BMX device. This device will take only 1 Gbps memory. Okay, that's the reason. Okay. So that is router 7. That will be 7. So G0 by 0, 6, 7, 7. So interface 2 already down, 0 down, and last one is 1. Interface 1. Interface 1 is connected with router 8. The IP will be 7.8. It is X is 7, Y is 8, and router number is 7. So, 3 interface configuration. 0, connect to 6, 1, connect to 8, 2, connect to 2. Let's move router 8. Router 8 G0 by 0 by 1. 0 by 0 by 1. Copy this one. This router 7. It's 8. 8.8. 1 done. 3 is connected with router 3. And the interface is 3. Interface is 3. That is 3. IP is 10.3.8. Contribute. 10.3.8.8/. Okay. So 1, 3. 1, 3. Next one is interface 2. Interface 2. interface 2 is connected with router 9, PMS 1, and interface 2 IP will be 898. The number is 8. Router is 8, interface configuration done. Then move to router 9. Router 9 is connected with router 8. Interface is 2. That is 8. MP 9. 8. Done. Another interface is connected with router 4. Interface is 4. So copy this one. And router is 4. Port dot, this is place configuration. 10, 10.4.9.9. This is okay. But this side interface IP will be router number. That will be 4. This 4 and router 9 will be 9. 2, 4. Last one is 3. 3 is connected with 10. 3 is connected with 10. And then address 10.9.10.9/20. Last router, router 10. Interface 3. Will be 10.10. Done. And last one interface is interface 5. Connect to router 5. Router 5. This is 10.10. Oh, so our loopback and point-to-point interface configuration done as per topology. Okay, so let's start for next. Okay, enabling core interfaces for MPLS. So first you have to enable MPLS, enabling core interfaces for MPLS. So what is the core interface? What is the core interface? See here, router 1, router 2, and router 6. This is one snap. from our topology. 1, 2, 6. See here. 1, 2, 6. This section. Okay. This section. Considering this portion, 3 router is connected with this. They are just showing the sample configuration. First one is enabling MPLS is a two-way or two-step process. So if you enable MPLS in your core router, you need to follow two steps. Number one is you have to enable family. You have to enable family MPLS. Okay, number one. In core interfaces on in core interface. Under MPLS protocol, you have to include this interface. You have to include this interface. Okay, basically this will be 0. So see here, enabling MPLS is a two-step process. First, add family MPLS to every core interface. First one is need to add family MPLS in all core interfaces. Number one, enable MPLS in the data plane. Second one is add the interface under MPLS protocol. Under protocol MPLS, you have to add the core interfaces. Similar configuration is added to all routers. Other router configuration will be similar. So there is two steps to enable MPLS in core interfaces. So let's start and do our configuration in our lab. So our core interface for router 1, the core interface is 0 by 0 by 0 and 0 by 0 by 1. This is the core interface. These two interfaces, core interface or MPLS backbone interface. In that case, first one or first step is unit 0 family. There is multiple families here. We have to enable family MPLS. This is the step 1. Step 2, set protocol MPLS interface, add your core interface. The interface is 0. So another interface is connected with router 1. The interface is C0 by 0 by 1. So same thing will repeat for interface 1. Okay. So your two-step already done. Show is the set. See here, the first step is family MPLS in core interfaces. Family MPLS in core interfaces. Under protocol MPLS, you have to add all core interfaces. Okay, so let's commit. Yeah. So same thing will be repeat for other stuff. So do this one. When we do MPLS 0, the interface is 1, another interface is 2, another interface is 2. So edit protocol MPLS set interface 0, set interface 0, 0, 1, 2. So first one is 0, second one is 1, and third one is 2. go for the three. Router 3 similar. Unit 0. This is 1, 2, 3. 2, and 3. Okay. Edit protocol. MPLS, sorry. MPLS. Set interface. 1, 2, and 3. Done. Router 3. So you can show this placement. Show this placement. Router 4. Go to router 4. Set interface. Family MPLS. 2, 3, 4. Next interface is 3, and last one is edit protocol MPLS. Set interface 2, 3, 4. 5, 3, 5. Double do minus 5. This interface is already MPLS 0 and 1. Edit protocol MPLS set interface 0. To 7, 1, 0, 1, 2. MPLS 0, 1, 2. Edit protocol MPLS set interface 0, 1, 2. This is repeated task. Already MPLS 1 to 3. 4, next one is 3. Edit protocol MPLS set interface 1, 2, 3. 1, 2, first one is 3. So first one. Good. Combine already MPLS 2, 3, and 4. 2, 3, and 4, edit protocols. Yes. Set interface 2, 3, 4. This router now robot plus 12. Bottom 10. 2 and this. 3 and then interface is 5. The protocols and MPLS and interface. This is 3 and plus 1 is 5. So all router configuration has been done. With enabling core interface for MPLS. This step. There's two steps basically. Number one is family MPLS and another one is protocol MPLS. Adding core interface. So let's go for next. Enabling core interfaces for MPLS. Why do you have to do this twice? Family MPLS, enable MPLS in the data plan. This is the reason why we adding family MPLS. Enables MPLS in the data plan. Protocol MPLS enables MPLS in the content. Okay. First one is data plan. Next one is for content. That's why we're doing twist type. Okay. Verification. After enabling MPLS, you need to verify. You need to verify. Is it your configuration is okay or not? Show MPLS interface. Show MPLS interface. Show you perfectly enable the MPLS in your core interfaces or not. If an interface is missing, add it under protocol MPLS. If an interface appears but is down, and family MPLS on the interface itself. Okay, so check status is up or down. The verification command is show MPLS interface. And here is another word is here, administrative group. So world is the slide. What is administrative group? But for now, you have to check the state. State is up or down. If down, need to verify your configuration. Okay, so let's start from router 1. Run show MPLS interface. Yes, both interface state is up. Interface state are up. Perfect. Okay. 4 out of 5. It's okay. Router 6. It's okay. 7. It's okay. 8. 9. And last. Your first primary configuration enabling or enable MPLS and core interfaces has been successfully done. Let's go into next step, static LSP configuration. So need to configure static LSP. Basically, static LSP is like static routing. Okay, you need to configure all MPLS backbone router. Okay, so say here, two things are to decide for your static LSP. Number one, what will you call it? Choose a helpful naming scheme. For example, you just uh, planning to configure one LSP from router 1 to router 5. You can set the name here, router 1 to router 5. That should be meaning. Okay. Which labels will you use? Labels. Here for static LSP, the you can start label is this value. This is the starting level and this is the ending level are reserved for static LSP. For static LSP, you have to start from this value and you have to end this value. This range is only for static LSP. You just see here the first label show here 1001212, that is 12, and from router 2 router 3 100 is fixed, the value is 2323, and here 100 is fixed 3434 because it's static. You can set the value by your choice. Okay. PSP between router 4 and router 5. PSP is router 4 and router 5. So there is no need and label. So this is the initial planning. When you configure static LSP. Your static LSP must be start with this file. Like we can consider here 100 and set the value, the router now 1, 1, 2, 1, 2. Just repeat it. Okay. There is 4 digits. Okay, then next move for next slide. Oh, check for understanding. Already we're in Q and answer section. Okay, so basically static LSP configuration in later is section. So let's do question and answer section. Which command can be used to verify the MPLS enable interface? Show MPLS interface. This is the command. Verify MPLS enable interfaces. Fine. And what are the configuration for enabling core interfaces for MPLS? Number 1, family MPLS to every core interface. And number 2, adding the interface under protocol MPLS. These two steps we already know. And this is the basically section of static LSP and how to configure the static LSP. Static LSP. This is static LSP. Just pause. Okay, so today we configure basically only you can say only basic configuration, or you can say only enabling MPLS in core interfaces. So next class we will do static LSP based on our topology. Okay, so today we want to close now. So next class I show you how to configure the static LSP and how to verify. So thank you very much. Bye bye. Allah Hafiz.